Welcome to Sundar's lecture. This is lecture number 50. So I'm very happy that I have posted about 49 lectures before this, and today I am going to post 50th lecture. So in this lecture we are going to see substitution theorem. So in the previous lecture we have seen superposition theorem, and we have found what is the current through this load resistance by a different procedure, maybe by activating the individual sources. We would have found what is the current through this particular resistance, and we would have sum up all the current by individual sources to get the final value of the current through this 3 ohms resistance. And in this class we are going to see a substitution theorem, and the substitution theorem will also help us to get a better insight in Thevenin's and Norton's theorems. It is not a particular theorem, and we are not going to find a current through a particular resistor, but it is a bit a different kind of thing. Substitution theorem, we will follow this one. So what I need to do here, we have a circuit here. So for that I am going to find what is the total current now. So how will you find what is the total current? This total current, maybe you see these two resistors are connected in parallel, right? This is 4 ohms resistor and this is 6 ohms resistors are connected in parallel, and this whole network is connected in series with this 0.6 ohms resistor. And if you want to find what is the total current I, so maybe I will be is equal to this. If I simplify this whole network to a single resistor, and it will be voltage 30 divided by what is the R equivalent. So it will be R equivalent. Maybe R equivalent means if you simplify this, you will get a single resistor. So for that, what I will do, I will put this is 30 divided by, so these two are connected in parallel, right? These two are connected in parallel, maybe 6 ohms and this is 4 ohms. So it will be 6 into 4 divided by 6 plus 4, right? So if you do this, you will get a single resistor, and these two resistors are connected in series now. So this will be plus 0.6, maybe, right? It will be, so it will be 24 if I multiply these two. So this is the final value. This will be 24 divided by 10. What is 24 divided by 10? It will be 2.4. 2.4 plus 6, you will get 3. So 3 and 3, 30, if you simplify, so it will be 10 amperes. So I will be is equal to 10 amperes. So here we are getting 10 amperes of current. And if I want to find what is the current here and in this direction, so this is nothing but I need to find the current value, and I need to find the current value here. So if I want to find what is the current in this 4 ohms resistor, so what here these two are connected in parallel, maybe 1 and 6, 1 and 5, 6 ohms resistance and 4 ohms resistance are connected in parallel. So apply current division rule. So if I apply current division rule, maybe I need to find, maybe I will put this as I1 and I will put this as I2. If I want to find what is I1, so I1 will be is equal to total current, that is 10 amperes into what is the opposite side resistor, 6 ohms divided by, maybe 6 means you need to add this is connected in series. 6 divided by what is the total resistor, 4 plus 1 plus 5, that means it is 6 plus 4, it will be 10. So if I cancel these two, I1 comes out to be, I1 will be 10 amperes. So this will be not 10 amperes. If you cancel this two, it will be 6 amperes, right? Maybe I have written it wrongly. So it will be 6 amperes. So this will be 6 amperes. I have written here 6 amperes. And if it is 6 amperes, then obviously 10 amperes is coming in, 6 amperes will go here, and it will be 4 amperes. Maybe we apply KCL at this point, I1 is coming in, 10 amperes is coming in, 6 amperes is going away, and 4 amperes should go away. So I2 should be is equal to 4 amperes. Right. So now we have found everything. We have found everything. That is this resistor will get 10 amperes and this resistor is getting 6 amperes and these two resistors are getting 4 amperes of current. Right? That is the thing we have found. Maybe I will write it here. I2, if you want to find how will you get I2? I2 will be is equal to, you see, apply KCL at this node. Maybe I will put this as A. It may take some time anyhow. So since you are very much trained to solve these kind of problems, so apply KCL at node A. I have to write so many things so that I have written it directly. Anyhow, we will write it down. So KCL. So I1 is coming in. This I is coming in. I1 is going away. I2 is going away. So I should be is equal to I1 plus I2, and this is 10 amperes we know, and I1 is 6 amperes we know. This should be is equal to I2, and finally I2 will be is equal to 4 amperes. I2 will be is equal to 4 amperes. And I1, this is 6 amperes, we have found already. So now we know what is the current through all the resistors in the network. Now what you can do here, what is the voltage? Maybe I will take this diagram, maybe I will draw this diagram again. Say I have taken the diagram again since it is very clumsy here to explain things. Now you see this resistance is having 10 amperes. And what is the voltage drop across this resistor? 10 into 0.6. What you will get? It will be 6 volt, right? So this is the plus and minus across this resistor, you will get 6 volt, right? And same way, what is the voltage drop here? V will be is equal to I into R. It will be 1 into 4. You will get voltage drop across this resistor will be 4 volt. And what is the voltage drop across this resistor? Again 4 ohms, 4 amperes is flowing here in this way. So this will be plus minus 5 into 4, it will be 20 volt. It will be 20 volt. And what is the voltage drop across this resistor? Obviously if it is 4 and if it is 20, 24 volt will drop here. That is what we are getting. 6 into 4, you will get, this is plus minus 24 volt. So we have written what is the voltage drop across each resistor by knowing the current through the resistor. And what I am going to do here, I can replace this resistor by 6 volt source. By a 6 volt, maybe I am not going to replace this one. I can replace this one. This resistor can be replaced by a 24 volt source. See, I will draw the diagram anyhow. Maybe it will be a bit of clumsy, not a perfect one, but anyhow, to understand things I need to draw this. So if I am drawing this like this, so this is 6 ohms, 0.6 ohms resistor, and what I am doing here, I am just getting like this. So this will be the diagram. This will be the diagram. So what is this one? This is plus minus 30 volt, and this is 0.6 ohms, and this is 1 ohms, this is 5 ohms, and this will be plus minus 24 volt. Try to understand, I have replaced the resistor with a voltage source. And if you simplify this problem to get what is the current in every resistor, it will be same. It will be same. Here you will get 10 amperes and here you will get 4 amperes. And through this branch, this is 10 amperes, this is 4 amperes, and through this branch, obviously you will get 6 amperes. Try to understand. Try to understand. I have replaced this resistor with a different source. Then also this circuit parameters, maybe the current through the other resistors or other branches will remain same. Or I can redraw this circuit like this also. See, I will do that. This is the 30 volt source. I am not going to touch this one. Maybe this I am not going to do anything with this resistor too. Now what I can do here, I can put like this. I can put a voltage source like this, and I can do like this now. So this value, it is plus minus 30 volt, and this is 0.6 ohms, this is 4 ohms, this is 5 ohms, and I can put this is plus minus 4 volt. And if you simplify this problem, to get what is the current in every branch, again you will get, this is, maybe you try to solve this problem. I am not going to solve this. I am just explain you the things, and this will be 4 amperes. This will be 10 amperes, this will be 6 amperes, and this will be 4 amperes. Again the circuit, the values or the current through other branches will remain same. Say I have replaced this 1 ohm source, 1 ohm resistor with a 4 volt source. But my circuit parameters is not going to change in the other branches. It is very interesting, right? Just we are going very deep into the electric circuits now. And maybe I will draw another diagram like this. See, this is the 30 volt source. And here I have a resistor. And see now, and I can put a current source here now. That is also possible. Now I can draw a resistor here, So if I do this one like this, 30 volt, and here it will be 0.6 ohms, and it is 1 ohm source, 1 ohms resistor, and this is 5 ohms. And now here, you can write it as 6 ampere source. And current direction should be like this, because we have found the current in this direction, so it has to be like this. And if you simplify this problem, again you will get, this is 10 amperes, and this is 4 amperes, and already this is the 6 amperes. So you can replace a resistor in a circuit. If you know the current through the resistor, you can easily replace the resistor with the equivalent voltage source, or you can replace it with the equivalent current source. That is the real meaning of substitution theorem. Actually, we are substituting the resistors with the source. Maybe it may be a current source, or it may be a voltage source. Now you see, this circuit can be redrawn in different manners. So that is the substitution theorem. See, we are not finding any current through a particular resistance with a different procedure. We are not doing this one. In the superposition theorem, we have done that. We have found what is the current through a resistor, but we are not doing it here. This is just a concept. You can replace a resistor with a voltage source or current source by knowing their values. That's all. So with the help of superposition theorem and substitution theorem, we are going to gain knowledge about so many different theorems in the electric circuits. That we will see in the next class. Thank you.